Question 11. The expansion of 1 plus x all to power of n, the coefficient of x to power 5 is twice the x to power 4 coefficient. Therefore, find n. We want x to power 5 and we want x to power 4. So if we have a situation where a plus b to power of n, we write it in this expansion manner using sigma notation, r starting from 0, n combination r, a to power n minus r times b to power of r, where a in this case equals 1 and b equals x, n equals n. But we're looking for two situations here when x is to power 5, so that means b has to be power 5, which means r has to be 5. So two situations, r equals 5 and 4. Okay. So the first situation is the coefficient of x to power 4, x to power 5 is twice that of x to power 4. So we can write when r is 5, which is that one there, so write n combination 5, 1, because a is 1, to power n minus 5, b is x to power of 5, you times in them, and that should be equal to 2 times the coefficient of n combination 4, 1 to power of n minus 4, x to power of 4, because that's what b to power of 4 will be, x to power 4. Now, what we need to do is try and simplify this. We don't need the x to power 5 or x to power 4 because we're just considering the coefficient. So we're just looking at the coefficient, and the coefficient in this case are just these two. So those are the coefficients. Coefficient is the number in front of x variable. So we want n combination 5 times 1, because 1 to power n minus 5 is going to be 1, and that should be equal to n combination 4, in fact 2 times n combination 4 times 1, again this is times 1, n combination r, we write it as n factorial over n minus r factorial r factorial. So if I'm writing n combination 5, it will be n factorial over n minus 5 factorial 5 factorial. Likewise, if I'm writing n combination 4, that would be n factorial over n minus 4 factorial 4 factorial. So we need to put this here. N minus 4 factorial can also be written as n minus 4, right, times n minus 5 factorial. I mean, let's give an example. If n was 8, so you can get 4 factorial can also become 4 times 3 factorial, because if n was 8, so 8 minus 4 is 4 factorial equals 4 times 8 minus 5, 3 factorial. So that's what, because it's always decreasing every time when you're multiplying factorial, decreasing by 1. Your factors, hence factorial. So now I could replace n minus 4 factorial by n minus 4 times n minus 5 factorial. I could also replace 5 factorial, which will become what? 5 times 4 factorial. So that's another thing I could replace. So I could replace 5 factorial by 5 times 4 factorial, and I can replace n minus 4 factorial by n minus 4 times n minus 5 factorial. So that's what I'm going to do next. So I'm writing that one here. So that's that one here. But I've replaced the 5 factorial by 5 times 4 factorial. So that's 5 times 4 factorial. I'm also writing n combination 4, which is 2 times n combination 4. So that's n factorial over what n minus 4 factorial is n minus 4 times n minus 5 factorial. So I've just replaced that here. Okay, so I'm writing this out and that one out, but I'm replacing it with these ones. But then I'm swapping the 5 factorial with this one and n minus 4 factorial with that one. Okay, now n factorial, we cancel n factorial because this is a ratio now. Also 4 factorial, we cancel 4 factorial, and n minus 5 factorial, we cancel n minus 5 factorial. So what do I have left? I've only got, so that implies that I've got 1 over 5 equals 2 over n minus 4. So if I cross multiply by n minus 4 times 1 and 5 times 2, I will get 5 times 2 equals n minus 4, which implies that 10 equals n minus 4, and that implies that n equals 14. So n equals 14 is the value of n that we're looking for.